Anshul with us, Mr. Anshul Sindhwani. He is Assistant Manager Geotechnical L&T Construction. Quick, brief introduction about him. So, he did his BTech in Geosciences from University of Petroleum and Energy Studies, Dehradun, and currently he is pursuing his PhD from IIT ISM only under Professor Murthy. He has been working in urban tunneling, so he has been associated with different metro projects ranging from Nagpur, Ahmedabad, Lucknow, Chennai, and he did several geotechnical and geophysical investigations along the TBM tunnel cross passages. So today he will be giving lecture on urban tunneling and various challenges we are encountered with and how to deal with them. Over to you, Anshu. Please proceed.
Yeah, thank you, sir. Can you please just confirm again I'm audible to you? It's loud
Yes,
and
yes, you
clear.
are audible.
Thank you. My screen is also visible, sir.
Yeah. Now the screen is visible.
Okay. Good afternoon, everyone. First of all, I would like to thank Murthy sir and Bhadwaj sir for giving this wonderful opportunity. So, having said that, like I've worked on various metro projects, specifically underground, including Delhi, Chennai, and Mumbai. So, I've seen bits and pieces of how exactly the urban tunneling challenges are and how unique it is in with respect to hydro tunnels or railway tunnels. So I'll just try to cover basics of what exactly we need to like look upon to when we are starting any project, and at the same time what exactly are the kind of challenges we can face in urban tunneling. So I'll start with, so basically I'll be covering, I'll start with urban tunneling, then we'll move to geotechnical investigations, how to do TBM selection. It's again a generic thing that mainly the parameters we need to see while selecting a TBM, then identification of critical structures along tunnel alignment because we are dealing with public. So this is one of the major concerns, and instrumentation and monitoring, risk identification, and then we'll end with the challenges. So if you see on the right hand side, this is the alignment. So I'm mainly talking about the Mumbai Metro, but then like having said that, I have experience of few other metro projects. So I'll be speaking in general as well what exactly the challenges or the works associated with the underground tunnel. So if you see on the right hand side, this is the Mumbai Metro package one, Kaffrade, Vidhan Bhavan, Churchgate, Hutatma Chowk station, and you can also see the Arabian Sea is very near to one specific location, and in general also entire alignment is very near to sea, so you can have a very predominant, a sort of a challenge that water could be a big issue in our case scenario. So, what exactly urban tunneling? Like urban tunneling, if we speak about, there are different applications associated with it. If you see, we have metro tunnels, we have transportation tunnels. Within Mumbai itself, all sort of applications of tunneling are currently being executed. If I talk about metro, so we have Mumbai Metro Line 3. If I talk about transportation tunnel, we have a coastal project running below the Marine Drive. If any one of you have seen the Marine Drive, so it's basically below the sea. We are building a tunnel which is having diameter of 12-meter. L&T is building it. So it is one of the largest TBM being deployed at the project. Then we have utility tunnels being executed currently by MCGM for water transfer and sewage. So all sort of applications are there. Then we also recently started with high-speed rail, which is in Ahmedabad. It is again a big, and the project is yet to be started specifically for tunnel, and again we'll be having one of the largest TBM of India deployed as on date. It is around 14 to 15-meter diameter. So all sort of aspects are there. Today I'm going to cover about the metro tunneling in general. So the major facts which we need to remember before, like, or I should say, specifically any of the application of tunneling project being executed in urban areas, what are the main key points we need to remember? See, ground surface is a unique challenge which we need to keep it as it is, or I should say, undisturbed, because public is staying on the top if there is any sort of settlement, everyone will be having a panic scenario, and then there can be very serious consequences. Then we have utilities, like specifically in Mumbai, we have utilities where even the owner doesn't know which utility is going from which location to which location, because it is being laid around 80 years back, 90 years back. So it's a big challenge which we need to see. Then we have a risk mitigation plan. Like I said, even though if there is a settlement or any sort of ground issues happening, there has to be a risk mitigation method at the same time. Before starting the project itself, we need to have a risk mitigation plan, that if, let's say, this scenario is happening, what is the probability of that event which is going to happen, and what is the risk mitigation plan in advance we need to see, because we are working below the existing buildings, we are working on a live traffic roads, so it can have a detrimental effects. Then the subsidence, which I have already talked about, it is one of the key major issue in any urban area. I've worked in many cities, and everywhere the problem still remains the same. Although if we have a risk mitigation plan in advance, we can always avoid these project failures. So, talking about ground subsidence, you can see these images from top to bottom, left to right. Everything is involved in and around the urban area. If you see on the right hand side top, this is a Bora Bazaar in Kolkata. Recently, some issues has happened last year during the pandemic time. Then on the right, left hand side, both images, if you see, it is from Chennai Metro Phase One. So, and this is from a foreign project. So what you can see in and around is public is involved, buildings are there, traffic is there. So at the end of the day, it's to the risk of public. So we need to avoid that. How we can avoid that? We need to have a specialized engineers like you, from mining, from mechanical, civil, from geology, from geophysics. Every bit of like every engineer is making a team to make it a project success. So I'll start with the typical stages of construction within urban tunneling. So if you see, we have a retrieval shaft and a launch shaft. You can also say that this is station one, this is station two. One station, we call it as a launching shaft, where we'll lower the TBM, and another station where this TBM will be retrieved. So if you see, at the end of the day, you will have a access from here as a passenger, and you will have access as a passenger from this side as well. So basically, there are two stations. How do we do it? So if you go step by step, you need to have an excavation of launch shaft and retrieval shafts. Then once the excavation of shaft is done, you can lower the TBM, assemble the TBM, and then drive the TBM. Once the drive is completed, you can retrieve the TBM. This is the basic stage of construction, which is usually being followed everywhere across India and across the world. So basic layout, if I talk about station, like I said, launch shaft and retrieval shafts. So these shafts are just a part of a station. If you see here, this is a cut and cover box, which we call it as a underground station, where you will have a access at a later stage to enter into the station and then go from one place to another place. So at each end, we'll have either a launch shaft or we'll have a retrieval shaft. Specifically in urban areas, most of the cases we will have buildings both sides, on left hand side, right hand side. If you see the bottom image, it is a section, basically indicates the excavation stage, where we have, like in case of Mumbai, we have a rocky strata. So at up to one point where this rock is starting, will have pile systems. We call it as retaining walls. It can be secant pile wall, a contiguous pile wall, depending upon the ground in different cities. But specifically in Mumbai, we have used secant piles, which we will bore up to the rock, and then from rock level, we'll have a open cut excavation. And then you can see westbound tunnel, eastbound tunnel. Basically, two TBMs will be driven from these locations. So if you see, this is an underground station view. This particular end is a shaft, which I was referring in the previous section, previous image. So this is one shaft where TBM has come, and on the other end there is a launching shaft. So here the TBMs will be retrieved. It will be pushed inside the station, and it will again launch from this side and go toward this side. So as you can see, both sides we have high-rise building. This is the Nariman Point next to Marine Drive. You must have seen it, many of you. So it's a critical juncture. This is a Vidhan Bhavan of Mumbai, where we have a legislative assemblies. So if you see the station, we have these strut systems, which I have explained in the previous section. We have a secant files both ends, and these struts are basically retaining this wall, and then we are excavating it down. This is the general layout. This is a TBM tunnel layout where we have precasted segments being installed at the backside of the TBM, and then that's how we move forward. So, like I have specified in the previous slide, that there are a lot of engineers from different backgrounds, which makes one team. So we need people from geology, civil, mining, mechanical background to have a composition of one team which can drive the project. So if I talk about the specific activities where we exactly need them, we have a topographical survey where we have buildings, roads, trees, manholes, poles, cables mapped just to have a future reference. And also when we are building or excavating anything, we need to have a exact location where exactly this particular building is, how much far is it from the center line of the tunnel or from the station edge. Then moving on to the next activity is geotechnical investigations. We do geological and geophysical surveys during different stages of project depending upon the requirement. And then geological mapping is for the open slopes and specifically along the face of the TBM. Then we do have building condition survey, which is just to see the condition of the building which are next to the project location. Then we have instrumentation, and then we have station and tunnel construction. These all activities I'll be anyways talking about in detail in next slide, so you can wait for a while to understand what exactly I'm talking about. Many of you, since you're already from tunneling background, you might have a basic knowledge of it, which I'll explain through this urban tunneling case study. So the previous section talks about just the activities. This is a sequence I have created just to understand how exactly we start the project. So any project, if you go it from the start, first we do the topographical survey. If you see the right hand side image, everything is marked. Then we do have a geotechnical investigations and building conditions survey. If you see, these different numbers are being allocated for different buildings. This is a unique identification number we create so that when we start the project, we need to have an understanding of how exactly this building is, how much high is it, how many floors is it, what is the foundation, so that whenever TBM is passing through, we need to understand in advance what exactly the precautions we need to take care of. Then we need to have a building repairs and support. Like I said, there may be a cases where building condition is not good. So we need to have some repairs and support as well. Then we have a ground instrumentation and the building instrumentation. So uh, the geotechnical investigations, you might be aware about the basic drilling procedures and laboratory testing, what we do it. I'll be talking about those things in a bit detail in the TBM selection part. This particular images are just shown to indicate that how exactly the geotechnical investigations can help you to plan for your tunneling performance, or at the same time to understand how exactly or how much there is a probability of any ground failures happening. So if you see, I have created these images in a sequential manner, so that once we are, let's say, once we are moving from station one towards station two, how exactly the geology is changing. If you see the first image, what we can see is both the TBM top ground. There is a layer which is named as shale with tuff bands, whereas our TBM tunneling is in grade one, grade two, grade three basalt only. However, as we move further, what we can see is along the longitudinal direction, this shale and tuff bands is dipping towards the tunnel alignment itself, and it is moving down. So this particular case scenario is identical, where we don't have any soft rock, or I should say fractured rock in face of the TBM. Whereas on the other side, this particular image, what you can see is it becomes a mixed phase. So the point I'm trying to bring out here is, if you don't have investigations done with without any planning to it, you will end up with something else which is not exactly what is being mapped during the tunneling stage itself. So these are the two images. If we move further, what you can see is this layer has gone actually below the invert. So if you go back from the first image and interpret up to this image, what you can see is as we are moving forward from the TBM, this particular fractured ground is dipping downwards, and as we are moving forward, it is going down, 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 and until it is going below the invert of TBM. And then the next image you see, this has disappeared completely. I mean, in actual ground, it would have been gone beyond the borehole depth. Within this borehole depth of 30 meter, what it indicates that this layer is no more. Now, as we move further, what you can see is there is another section where this particular fractured rock has appeared again, but with more fractures in it. And then if you move forward, there is another layer which has added to it. So if you talk about in real terms, I would tell you this is just a 500 to 800 meter alignment which I'm talking about, and within those 800 meter of tunneling, you can see what exactly is the how exactly the geology is varying. So, point again to bring out here is the investigation's importance. If you don't have a detailed understanding before you select any TPM, it would be basically a plan to have a catastrophic failure later. So now I'll talk about the TPM selection part. Here I'll talk about which exactly the parameters we look for during the geotechnical investigation stage. So in Mumbai, we have used a crossover TPM, which is a dual mode TPM, first time being deployed in Indian conditions. I'll tell you what exactly is the difference between the TBM which we are using and in general it is being used. This is just a general classification of type given, which most of you might have studied already. We have a rock type TBMs and then we have a soft ground shield TBMs. In specifically in Indian cities, majority of the cities use EPB and slurry shield TBMs because of the soft ground conditions. But cases like Mumbai and Bangalore, we use rock TBMs quite a bit. But majority of the case we use EPB and slurry shields only. That also can be used specific in rocky conditions, but like specifically for Mumbai, majority of the people have used rock TBMs because we are working in Deccan traps, which is dominant of rocks. Now, coming on to the parameters which are most important for the TBM selection, there are two categories in this. One is ground condition, of course, and second is based on these ground conditions, what exactly the TBM operational parameters we look for. So, in ground conditions, we have intact rock characteristics and rock mass conditions. Intact rock, when we talk about, we need to have a strength part of it, then the toughness, then the hardness, drillability, brittleness, abrasiveness, Poisson's ratio, elastic modulus, and many more like porosity and grain size, which are basic to it. And then rock mass conditions. Cases like urban tunneling, you don't get to see these rock mass conditions because there is no, uh, rock mass exposure exposed. Like if you go to any hilly terrain, you can map the slope which is next to the tunnel alignment, and you can have some sense of understanding. But when it comes to urban tunneling, all you have is the boreholes which goes down up to the tunnel alignment. But anyhow, basic things you can understand is what exactly is the spacing. It could be with reference from the RQD which we calculate. It can be related. Then the dip amount, like generally we get to know the amount of dip from the course, how much it is having an angle with respect to the horizontal. So basic things you can understand, but until and unless you don't have exposure, it's hard to get before the project starting stage in urban tunneling. Now, moving on to the TBM operational parameters, see these thrust force, torque, RPM, power, these are highly dependent on the ground characteristics. And until and unless we don't have an idea of the previous section, we cannot get into these parameters. But as a holistic view, these parameters are what we look for. Number of discs, like if I talk about a very specific case scenario, disc cutters like what we are using in Mumbai is 17-inch disc cutters. It is fair enough for a rock of strength of up to 150 MPa, but cases like Bangalore, where we do have a very hard quartzite rock with very high abrasivity in nature, the experience in the phase one Bangalore project was that 17-inch disc cutters that didn't work well. So this time, as an L&T, we are using 19-inch disc cutters. So that is how a dependency of these disc cutters can have on individual projects. So what we are talking about in terms of the key parameters when we look for any TBMs, what is the maximum advance speed penetration? Because this will again reflect the planning of our tunneling construction schedule. Until and unless we don't have some values attached with it, now this will get only when you have a ground characteristics available. Then what is the range of speed of cutter head? Then the main drive torque range, power of main drive, total thrust force, total number of cutters, how many gauge cutters, how many face cutters, how many center cutters. All these details you need in advance. So you might be aware already there are many TBM manufacturers. These are just I've named a few which are mainly involved in Indian tunneling. Heron Current, Robbins, Terratex, CRCHI, CREG, Lawson's. In fact, I've worked with at least three or four. So these are the major players what I have seen personally in India. So moving further, like I said, these key parameters are basically being derived from the ground characteristic which we get. So usually, if you ask a technically, if you ask me, there is a back calculation that how much advance you can do within a day or within a week or within an hour based on these TPM performance prediction models. But personally, what I've seen in construction industry, mainly the construction schedule is way beyond these performance models parameters because it is more dependent on the logistics parts of it than the mucking because like in case of Mumbai, our muck is being disposed 60 kilometers away from the project site. So even though we have more mining meterage in advance, like more mining in advance, still we will not be able to dispose of the entire mug and therefore the TBM will sit idle. But in any case scenario, if you want to have a rate of penetration or the advance rate in advance based on the ground characteristics, you can have these models. You can use it is again based on different logics. There is a theoretical experimental models and there is an empirical models based on laboratory and field studies. So you can have a combination of all of these based on the availability of the parameters of ground which you have done or covered in the investigations part. So just to give you a actual case scenario when we do mining, what exactly we get. Now, up till now, what we have spoken about is just the parameters. This particular screen I have extracted exactly from the TPM operator's screen, where how you will get all these parameters, what exactly is changing, how much it is changing. I'll just give you a few parameters as understanding. If you see this speed, it is 27.9 mm per minute. It's basically indicating the penetration rate of TPM per minute. Whereas if you see this force, it is 11,000 case scenario. So as a geologist, I can see just looking at these parameters that this must be a rocky condition ahead of the phase of TBM. So if you see the cutter head speed, it is 2.45, torque is 3655. So these are just the parameters which, as a geologist, also I need to see, and then overall the TBM operators are highly dependent on these parameters. So this is just a different view. I've taken majority of the parameters which I have just listed in the previous section are again being noticed here. Cutter head speed, torque, then you have an advanced ROP thrust force. So if you really talk about like a mechanical engineer point of view or a mining point of view or a geologist point of view, these are the parameters which can give you a lot of idea of what exactly is happening ahead of the phase and within the phase itself. So moving on to a next topic, it might be a unique or a bit, a different topic you might have not studied as of now. See, building conditions survey is, I've spoken earlier, it is basically to understand the existing condition of a building before the start of the project. If you see this image, there is a deck here and these are buildings just next to it. So it's basically a station underneath this deck. We have excavated up to 30 meters. So you can imagine if you don't do any survey of these buildings, you cannot go out and just execute the project because these people will come and say that, "Yeah, because of this metro, our buildings are getting shaked every time," which might be a case, which may not be a case, but that is what you need to identify in advance, which we call it as structural audit and building condition survey. So I'll just speak about this in detail now. So first activity when you go in any project, this is the tunnel alignment. You just go and mark this 50-meter zone from the center line of the tunnel towards both ends. This is westbound, eastbound. This 50-meter zone is nothing but the influence zone which is being written in a contract of every underground metro project across the world. This basically means that even though the worst case scenario is you have a soil ground conditions with flowing ground, the maximum extent it can affect is 50 meter. That is what a basic understanding. So point is this 50-meter is taken as the worst case scenario, that whatever be the ground conditions beyond this 50-meter zone, they will not be having any impact. Depending on the project, this may have effect up to 5 meter, 10 meter only. But this is the 50-meter zone which is being contracted and written in every contract, that this is the zone which you need to cover for identifying the existing condition of a building. Because even though we have a rocky condition in Mumbai, it will have effect of let's say 5 meter only. Still, this 50-meter zone building can always claim that it is because of you. So we need to have the understanding of the buildings in this 50-meter zone. So scope of building condition survey, what exactly we do? So we start with identifying the existing defects. Like we go, let's say if it is a G plus 4 building, I'll just take this example. It is a G plus 2F plus roof. It is ground plus 2 floors plus roof building. It is an apartment. What is the type of construction? Reinforced. You can see the age of building is approximately 100 years. What are the dimensions? What is the distance from tunnel alignment? You can see it is 22.5 meter. What is the foundation type? Isolated footing. It is written as based on the structural assessment. So this is basically an assumption. When these details are available with the owner, it is a proof that this is what the foundation. This is just an assumption because owners usually don't provide it. So what we do is we record all these defects in a report. Let's say this particular plan I've taken where you can see there are cracks on wall is marked here. Then you have cracks on wall here, cracks on wall here. So what we are doing is floor by floor, we are identifying the existing defects. This is what written here. So then we do record all these defects in a report. Then we assign a category. If you see this particular page, there is a damage category, and we have categorized this building as very slight. I'll show you the table, what exactly is the categorization we do. So very slight indicates that the building is in a quite good condition and it doesn't have any major issues like spalling or corroded reinforcement or sort of things. In case this damage category is being assigned as let's say severe category, which means the building is in a very bad shape, we also do structural audit. Now, structural audit is a authentic way of identifying the condition of the building by doing some testing. What testing we do, that also I discussed. So basically, we do NDT test to check the severity, and then we also prepare the propping and the repair plan for those buildings. So if you see the right hand side, these are the 4 or 5 major categories we define these structures into. It starts from negligible, very slight, moderate, severe, and very severe. Very severe indicate that the building is in a dilapidated condition, like a very poor category condition. Whereas negligible indicates it just contains minor cracks. So these are just the photographs which I was talking about in the previous slide, that these cracks are being marked for every floor, and these cracks we include in the report itself, where we do mention the location. If you see specific location, stairs to third floor, minor crack, what is the length, what is the width of crack, all these things we do have an engineers which are specifically allocated for this survey. And then at the same time, if you see, these are the same parameters which I talked about. it is from a station boundary, how much is the distance, what is the foundation type, what is the depth. It is again a structural presumption. If let's say we don't have any details available, we do physical checkups of the foundation. I'll show you in a next slide. So you see here, in Mumbai specifically, we have heritage buildings to deal with, which are almost 150, 120 years old buildings. So nobody has the detail of how exactly is the foundation. So if you see, our designers have marked it specifically by digging a trench. They have come and visited and see what exactly is the type of material they have used in the foundation. So for heritage building, this is sort of a foundation they have used. So this is also a way to do it. Nowadays, if let's say we have a high-rise buildings in Mumbai, we know it will be definitely on a pile foundation. So some basic understanding is also required. Otherwise, trial beds are always the best way to understand what exactly is the foundation. So I was talking about the severe buildings. You can see these damages. These damages we have identified in some of the buildings and we have categorized as very severe. You can understand without even any project construction, these effects are already existed. Imagine if we have a tunnel below these buildings, what can have an adverse effects on these buildings. So this is again one of the important category. Along with the buildings, we also need to identify these bore wells or wells in advance. Now, many of the cities like Delhi, Chennai, or Patna or Ahmedabad, we do have a bore wells within every building to have a water supply. And when we plan these alignments, nobody knew that these bore wells are next to the tunnel alignment or in front of the tunnel alignment. So these bore wells needs to be plugged before the TBM arrives, and we need to have a separate arrangement for the owner. In case of Mumbai, we don't have bore wells because we have a rocky strata here, but we do have many holy Parsi wells, which is again like a open with without any foundation wells. It's basically in within the sandy or soil strata of a ground, and it is a open basically from the bottom. So you can have a ground seepage in when you have a tunneling. So these again wells you cannot do much because it's a holy wells. Since it is a rocky strata in Mumbai, so usually the probability of any ingress happening within the well is less, but then anyway these needs to be monitored. In case there is a seepage within the TBM, then this water level will go down. So again, people will panic. So point here is these borewells and wells needs to be identified along with these buildings when we are doing this building condition survey. So I was talking about the structural audit. Structural audit we usually don't do for every other building. We do it only for the buildings where we feel that it is very severe and it is very near to the tunnel alignment and it will have an impact for sure. So what we do is if you see, we do ultrasonic pulse velocity test, then we do rebound hammer test. People who are from civil can more relate to it, these tests. Then we have a carbonation test, then we have a half cell potential test. So basically, we go inside the building, we take a core from the concrete, and we do some testing to come to a conclusion how much severity it is. So at the same time, the detailing of the cracks which we have done in the building condition survey, this is the advanced version where you see extent and the exact critical component of that building is being marked here, which needs to be treated. So basically, the structural audit not just tell you that what is the condition of the building, but it also tells you that where exactly you can do some additional propping or repairs so that building can have a substantial basically weightage to have to allow the project to do something. Like if you dig below this building, then we know that there is an impact for sure. So what additionally we can do so that we can do the tunneling. So some supporting and some repairs are required. So this structural audit will tell us where exactly you need to prop or repair it. So that again I'll tell you here. So if you see this image, in the first image, it just show you what exactly is the damage. If you see bottom, it tells you it is a ceiling structural damage, beam damage, or a column damage, or a floor structural damage. And on the right hand side, it tells you where exactly you need to put some support If you see here, it is just a wooden batten and prop we need to use so that it can have some structural integrity so that it will allow our tunnel to go through. So once this building condition survey is done, these identified defects have been completed, ground investigations have been completed. We do the ground movement and building risk assessment studies. I'll just again repeat here. Now it's the second stage. If you think it in this way that we do have a buildings which has their own condition, then we do have a ground which is again of a specific type. Now, when we do tunneling, these two things basically interact. So if it is a soily ground, these buildings are already in our existing like severe condition. So when you do tunneling in soil ground, it will have a tendency to settle more. Whereas if you have a rocky ground and the uh, building category is still critical, you will have less impact because the ground is strong. So in this particular case scenario, we do the ground movement studies and then we again categorize these buildings through a risk assessment approach, where we identify that okay, this is the ground, now what exactly it will have an impact on the building. So if you see this is the tunnel alignment. If you see these three lines in between, there is a center line, and then there is a different line we have plotted here. This different lines are basically contours which we have identified for different amount of settlements. The one which is nearest to the tunnel alignment indicates highest amount of settlement which can happen. Whereas this red category indicates that this is a contour of 1 mm contour, which indicates that if you go this much up to this much point, there will be only 1 mm of settlement. Now imagine if you have a building here and there is a 1 mm settlement here, even though this building is in a severe category, it will not have any impact. So this is what we do in settlement analysis and contours plan. We mark these contour lines all along the tunnel alignment, and then we identify these buildings, what can have an additional impact based on our construction. So this building risk categorization I was talking about. So based on this categorization, I am going to plan my instrumentation now. So this is again, you can refer it as from negligible to very severe category. Green indicates that no preemptive measures are required and we can have a basic instrumentation plan. Whereas the red category indicates that sometimes this building is so bad that we need to have a temporary or a permanent evacuation, or in some case scenario we can have a demolition of the building as well if required. And then at the same time, if demolition is not possible, we need to have a enhanced instrumentation and monitoring. It could be a real-time approach or it could be any different way of doing it. Then we need to have a temporary repairs and support plan, which I have again discussed in the previous slide. So this particular approach gives us a plan of doing instrumentation within these buildings and what exactly is the support required in these buildings. So moving on to building support and repairs part. Now imagine you have done the studies already and you have come to a conclusion that the supports are required within this building. So what sort of support? If you see the left hand side, this wooden batten I was talking about in the previous image where I talked about the structural audit, this is being supported here. If you see this, we have a heritage buildings. We have a station excavation here up to 30 meters. This building is just 2 meters away from our secant pile alignment. So these arches have a tendency to either converge or diverge based on the excavation. This is what the probability which we have thought that it may expose this thing. So we have supported. If you see these arches, we are supported by these I sections here, ISMB sections here, so that it can have again a structural strengthening. So, I was telling about the heritage structures of Mumbai, you can see we have these finials. These are basically UNESCO identified heritage buildings. So they have a unique finials or structures type in their building. If you see this, these finials are being supported by putting some counterweight here. The same thing is done here. It is just a bird eye view. This is a close view of the arch support, and then this is a projection which people like heritage building have given long back. So these projections needs to be supported, because imagine there is a blasting, we have done blasting just next to these buildings, so these projections have been supported so that there will be no fall below. Then we have also done some repairs for few buildings, which we have concluded that it is very severe and it will cause further deterioration because of structure. So why not to repair it in advance? So this is a basic, I would say, path flow in any underground project if you go. So if you see, there was already a structural crack in a beam, which is a major thing for any building, because these beams are going to take the load. So we have chipping off this plasters, done some additional reinforcement, done the concreting. So you see, this is the final. So you can imagine, just to save public, how much deeply we need to dive into to make these buildings safe and free from any effect due to construction. So now I'll talk about the instrumentation and monitoring part. Instrumentation and monitoring is again being divided into different categories, in a sense that we need to monitor buildings which are in the vicinity, but at the same time, what we are digging, like for stations, what we are digging, that structures also needs to be monitored. Like I've spoken about the open rock cut slope, these piles, retaining walls, struts in between. So all these structures also needs to be monitored, because the workers who are working inside the station also need to have a safety at the same time. If anything happens within that station, ultimately it will lead to impact on the buildings which are in the vicinity. And then we have a tunnel instrumentation. So basic, if you ask me, the objective of doing this instrumentation is to have a construction safety, then check on the ground behavior and the construction progress, verification of design assumptions, safety of these buildings and structures, evidence to damage dispute. This is again a major thing here, because people tend to say that wherever this metro works are going on, it is only because of metro. So that is not usually the case every time. So this particular data, instrumentation data, gives you an evidence to any damage dispute being happening in future. And then it is a contractual obligation. So if you talk about buildings, what exactly the instruments we use? See, these instruments will still remain the same now. Point is whether you are doing it manually or real time, it depends on project to project. Like in case of Mumbai, we have done both manual and real time, whereas in Chennai, Delhi, it has been done mostly manual mode, but then some specific case scenarios, some critical buildings, we have done real time as well. So, point is, what exactly are the type of instruments we use? First is 3D target, which is nothing but it gives you a three-dimensional view or three-dimensional coordinates of the building wherever we usually install it at. Let's say if it is a 10-floor high-rise building, so you put it at after every 3 floors. So it's, let's say, 0, 3, 6, 9, and then on the roof. Then you have a tilt plate, which is basically a bidirectional understanding of a building. Let's say if you are doing an excavation in front of any building, there is a tendency of building to get tilted towards the station direction. So we install these tilt plates. It gives you a two-dimensional view. It gives you this view as well as it gives you this view also. Then we have a building settlement marker, which is nothing but we install it. It gives you a direction in Z. So it will give you a level. If there is a settlement, this level will change. Then we install this crack meter. So if you remember, I have talked about the cracks identification during the building condition survey part. So those cracks which have been identified in these buildings, later before the construction, we install these crack meters, because we need to know during the construction stage if these cracks are getting widened or not. Then we also use vibrometer. It is a micrometer, basically to monitor the vibrations. So you see, we are doing piling just next to the building boundary. So when we do piling in hard rock, it creates a lot of vibrations. So we need to monitor these vibrations. In fact, during excavation for blasting, also we are doing it. So station monitoring, like basically this station monitoring consists of monitoring the structures within the station and the ground beyond the station. So this particular slide talks about the ground beyond the station boundary. So we do have either roads as well, some in some cases scenario, also in some case scenario we do have ground, open ground. So we install these pavement markers on roads and this soil settlement marker on ground. Then we install this standpipe piezometers to understand the water level. This water, maintaining the water level in the cities is a very critical challenge, and it is a contractual obligation that due to our excavations, we should not lower the water table because it will have a major impact on the buildings in the surrounding. So we need to have this standpipe piezometers everywhere to understand the drawdown if anything is happening or not. In case it is happening, some uh, wells to be digged and then additional work to be done. Then we also measure the pressure of through vibrating wire piezometer. We calculate the pressures in MPa, what exactly is the water pressure there, because if height is getting decreased, water pressure will also change. Then we also have a soil inclinometer. If there is a deformation at any point, it will get to know through inclinometers. So this is basically the instruments which we are using beyond the station boundary within the ground, or we can also call it for deep ground monitoring. Whereas in tunnel monitoring, same type of instruments are there, just that we also use extensometers, which we call it as multi-point borehole extensometers. This is just to understand the deformations at different levels. Let's say our TBM tunnel is at 15-meter below the ground. So basically that crown is at below 15-meter. So we can have a multiple point extensometer at different levels. Like we use it for 6-meter, 9-meter, and 12-meter. So like that, you can have a understanding at different depths. So this is just one case example and showing you how exactly we monitor a building. You can see the building on the right hand side. It is a heritage building. So you can see this orange dots. So this is nothing but these are piles being done next to the station. So you can see this distance is hardly 2 meters. So within this area, the excavation is done. This is a previous image where there was no excavation. So what we do is within this building, if you see the left hand side, at different levels we put 3D targets. Then we also use building settlement points here. Then we have also used in this heritage buildings, we call it as tape extensometers. Uh, the other image I was talking about, these arches we anticipate it may converge because of excavation, although nothing has happened, but this is what our anticipation. So we have used the tape extensometers, we have put the hooks at both the columns, and then we have calculated the distance. If there is any convergence or divergence happening, we'll get to know. So then we also put vibrometers at different levels whenever there is a blasting. So these finials I was referring, which we have supported. If you see the plan view, there are almost 10 to 12 statues here, which is being reflected here in the section form. So these are being supported by a counterweight balance. So all these things are being done just for a building. So you can see this blue marks. It is a tilt meter which we use it to see if there is any tilt in the building or not. So this is just a basic view I have told within a single building how these instruments have been placed. Same has been marked also, if you see. Tilt sensor we usually put at the ground and sometimes at the roof as well. Because roof is majorly, when there is any tilt happening, roof is the worst affected zone. So for these instrumentations, we have different review levels as well. So it's an alert level, action level, and alarm level. So these three levels are nothing but just imagine you have a rocky subsurface, basically consisting of bedrock, competent rock. So the allowable settlement for any building to happen based on the contours plan which I've shown earlier. Just assuming, let's say if 10 mm of settlement is what maximum allowable settlement for any building. So 50% of it is a alert level. So 5 mm is a alert level zone. 80% of it is a action level. So which means 8 mm is the action level. Then you have a alarm level which is 100%. So what we do is when when there is any instrument reaching the alert level, what we do is we increase the frequency. Now, frequency of monitoring again depends on project to project, but in general case scenario, during excavation, it has to be on a daily basis. Once the excavation is done, the frequency can be decreased. In case the TBM is just passing below through the building, it should also be increased to, let's say, every 4 hours, every 12 hours. But now for alert level, if alert level 50% of the reading has already breached, what we do is if it is a daily reading frequency, we'll be reducing it to 12 hours. And then it also depends on the rate of which this reading is increasing. Let's say every 1 week, just 1 mm is increasing, then even 12 hours reading is fine. But let's say this reading is increasing by 1 mm every 2 hours. In that case, the frequency also needs to be increased. So it also depends not just on the amount of alert or action or alarm has happened, but it also depends on the rate of increase of the reading as well. When it is reaching action level, it means that it has already breached 80% of the design limits specified, which also means that there has to be contingency measures in place. Let's say if it is a ground settlement happening in front of the road, or I should say in middle of the road, then in that case, there has to be a traffic closure. If there is a settlement happening and it is continuously increasing, so there has to be a contingency measures, not just the traffic closure, but at the same time, some additional plates or something needs to be put on top so that it will, even if it will go down, it will have some sort of stiff support on the top so that people will not get affected. So based on the case scenario, different contingency measures needs to be prepared. Now, if let's say now until now there is no work stoppage, work will still be continued until the action level. But when it is reaching alarm level, the first thing we need to do is to completely close the works in that particular area, and then at the same time whatever the contingency we have planned, that needs to be in place. And at the same time, all local authorities like fire brigade or police or whosoever is the government authority, we need to inform them. At the same time, clients as well, that this is what has happened. Now we need to do something, but then for doing something, this is what is the requirement. Like traffic has to be closed, people have to be evacuated. So for that, it's sort of a cooperation from all the authorities which will be in place to understand what exactly we can do mutually. Now, risk identification along tunnel alignment. So if you see this particular image, if you remember, in the initial slide, I have shown the alignment was very near to the sea. So this is the image where I've taken the picture. Just below, we have a tunnel alignment. So you can imagine how much close it is. It is within a range of 15 to 20 meters. This is a high tide zone. So you can imagine, as a basic understanding, there will be a tendency of high water pressure or high water ingress during the tunneling stage. So this is a basic risk which we have understood even as a layman if we don't even have a understanding of what exactly things work. This is a basic picture I have shown to understand and talk about what exactly are the risks associated if you go along the tunnel alignment. So first is I talked about the nearest location to sea. So this is what first thing which is vulnerable. Second is borehole location. See what happens is when the initial alignment is being decided, boreholes are being done in those stages. Now when later on the contractor arrives, the alignment may get changed. So these borehole locations, which initially were digged along the tunnel alignment, can go and fall away from the alignment as well. The images which I have shown earlier regarding the geotechnical investigations, what we have understood is as we are moving forward, the geology is changing. Even if we are moving left and right, it is changing. So imagine if these borehole locations are being um, like changed at a later stage, it can have a major impact. But now, what can be done? The only mitigation which can be done is we need to have a mapping of these ground during the TBM excavation stage when we do any cutter head inspection, we can also need to have a face inspection at a regular interval so that we do not miss anything. Vibrations in urban alignment, again, like I said, see, there are two things related to vibrations. First is the technical part of it, which we call it as peak particle velocity. If that is going beyond the contractual or allowable limits, yes, there will be problems. But on the other side, what majorly we have experienced until now is, even though there are no vibrations reaching up to the allowable limits, still people get discomfort because people hear these loud sounds, they get irritated and it create discomfort as well. So what we need to do in this case scenario, we can have a dedicated licensing team. They'll be available at surface locations. So in Mumbai, we have done 200-meter of Natam tunnel excavation through blasting below severe category slums. So you can imagine at every single blast, these slums people are like local gundas of individual areas. So they can have a huge impact on a project because they will come with their community and they can treat us like anyway. So there has to be a licensing team which will be there always. So what we used to have is every before every blast, we tell them in advance that we are going to take a blast, so people get alert. Then another challenge is, or another risk I should say, is we need to identify bore wells, like I said in advance. But still, there is a high probability that some bore wells still get missed, because what happens is there are some buildings where the tenants are staying. So the tenants are not aware that there was a borewell initially in this location, which has been later on filled. Nobody knows, but when there is a TBM tunneling happening below, the grout will come out, then people will get alert. So in any case scenario, there will be a loss of grout on surface, which can again have a serious issue on people. I still remember in Chennai, we have these leakage of grouts on surface through people, like toilets, people bedrooms. So it creates a lot of discomfort, but at the same time, people get panic and angry as well. But what you can do is you can need to have a continuous visual inspection. So what we usually do is, wherever the TBM is, we always have people on surface to identify if there is any leakage happening. At any moment anything has happened, we decrease the pressure so that basically the grout which is coming out will not go out. So that is what the best you can do. Groundwater inflow, like I said, drawdown of water level can lead to settlement. So in our case scenario, like I said, we had this TBM which can run both in open mode and closed mode. So what we need to understand is, if we are allowing the water to come inside, it will have an impact on the outer side, which will draw down the water level. So what we can do is we can close the TBMs and we can run these TBMs in a closed mode. So that provision needs to be there. How this provision will come? You need to have an understanding of the ground conditions. If there is a high water table in any city, you need to have this provision in advance. Now weak ground again leads to higher settlements. So what we can do in weak ground is we need to have a adjustment of operational parameters of TBM. If we can do that, we can always avoid these settlements. Then old structures, what happens is, when, like I said, even if the building is critical and at the same time our ground is weak, it can have again a higher settlements. So what we can do is support can be provided, extra propping material to be stacked at that particular location, and emergency response team also needs to be formed. So these contingency measures needs to be taken in advance if we see there is any possibility or how much is the probability of this particular incident happening. So this identifying risk is one part of it, but then at the same time, what you have done with that identified risk. So in this case scenario, for old structures, we have kept some support material and propping material in that particular building when the TBM was closed near to that particular building, and there was an emergency response team allocated. So those sort of mitigation plans needs to be placed in advance. Then there is a dip in geological strata. Now, in case of Mumbai, like I have shown these previous images, there was a dipping strata from one location to other location, means one TBM to another TBM. As a geologist, I can say that, okay, I have mapped TBM 1. Why should I map TBM 2? I know already the strata, what exactly it is. But it can have an impact on the other tunnel because the strata which is ahead of the TBM is dipping in one direction. So you can have different type of geology at specific changes. So you need to have a different mapping. So this is again a mitigation of what we have identified in advance. So this was all about the urban tunneling main risk which I have specifically experienced. Then now I'll compare some of the challenges with respect to the hydro tunneling, because see, hydro tunnels are much more famous, are actually being evolved much earlier than the urban tunnels. So how exactly we relate both? Because people work in hydro tunnels can sometimes face issues in urban tunnels, and same for the other part as well. So vibration limits, see what happens is in hydro we have like for an individual blast, what I have heard and what I have sometimes experienced is the total explosive weight goes up to 1 ton as well, 50 kg, 80 kg, 1 ton. But imagine in case of Mumbai, the maximum explosive weight for a single blast can be as low as 2 kg, 3 kgs. So this is just the explosive weight I'm talking about. Now, if I talk about the PPV, which is the peak particle velocity, in case of Mumbai, below the heritage buildings, we were digging a tunnel, and the vibrations were just as below as 2.54, and we were doing blasting below the buildings. So you imagine how much is the difficult part to excavate the hard rock with such low vibration limits. So this is the main difference between hydro and urbans, if you see. Now blasting, this I have already talked about. So within Mumbai, due to this less allowable vibration limits, the number of holes what we have taken for single blast is maximum of 8 to 12 holes. So if you compare with hydro, full-fledged blasting can be done in at least production of 2 to 3 meter per blast. Whereas in our case scenario, we have excavated 1 meter advance in 4 to 5 days. So urban tunnels, you just need not to see the ground lying ahead. You also need to see the buildings which is lying above. Because in our case scenario, we have heritage buildings above. So if you see productivity, like I said, time cycle increased, reduced productivity. Then pre-blast activity also we have done a lot of pre-blast activities. We have created a free face through drum cutter. We have done additional line drilling. Whereas in case of hydro tunnels, it is done on a case-to-case basis, but mostly line drilling is being performed to ensure smooth profile. In our case, we have done 102 holes dual in a dual line category just to reduce the vibrations, and then the vibration monitoring itself. See, in hydro, what happens is you just place 1 or 2 or 4 sensors at, let's say, 50 meter, 100 meter, 150 meter. In our case scenario, there were at least, let's say, 8 buildings near 50-meter zone at the blast location. So all these 8 buildings at multiple floors, we need to have these vibration sensors, because if let's say we are monitoring just on the building which is lying above, we know that the building vibrations will be there in the next building as well. So we need to have at least 8 to 12 sensors for a single blast. So this is how difficult to work in urban. So moving on to the last topic is challenges. If you see this particular image, you can see one side we have this heritage buildings, in between we have a station excavation. The other side, which is not visible, there is again buildings, and below this we have a tunnel. So if somebody as a layman also see these images, can understand that what exactly are the challenges. If you see these utilities, these pipes are nothing but hanging utilities. I have talked about it at the first place. These utilities were there. We have to excavate where exactly these utilities will go. This side also you have building. This side also you have building. So this is one of the challenge which I am showing you. Anyways, I'm going to discuss some specific cases in a later slides. So this is one station. I'm just showing a photograph. All along you have these heritage buildings, and when you have a blasting below, all these buildings needs to be monitored. So one of the major challenge in ground challenges in urban tunneling is water. If you see this right hand side, this was my first project, Chennai Metro. You can see up to my waist, we had this water. So back in 2017, there was a 2016 there was a floods in Chennai. At the same time, during excavation of cross passages, we hit groundwater badly, and the entire tunnel was flooded that time. So if you don't take mitigation plans or identify these problems in advance, you will end up with these images. Although I have a smile on my face, but this was really challenging, and we have avoided a catastrophic failure during that time. So coming on to the point is with the continuous increase in traffic and populations, we know these underground metro projects are becoming more and more, and it is of utmost importance. But these unforeseen geological conditions are a major contributor. You take any project, being it Delhi, Chennai, Mumbai, Ahmedabad, underground ones only I'm talking about, everywhere some sort of unforeseen geological conditions occurred, which has caused damages to buildings. In fact, I just mentioned about Kolkata Metro as well. So there was a damage to building. At least, if I am not wrong, there was 4 to 5 buildings which have partially collapsed, and it has suffered a lot of people. So ultimately, it results in cost and time overrun. In urban, again, what happens is you have a shallow excavation. We are talking about 15 to 20 meter to 30-meter depth. So this particular depth ranges with the overburden material, which makes things worse. Because see, when you are working deep underground, let's say at a depth of 50-meter, 80-meter, majority of the case scenario, it will be a pretty, I should say, strong rock or self-standing rock. Whereas in case of urban excavations, majority of the case scenario, this overburden material, which is like, let's say, from 0 to 10 meter, causes majority of the problems. So what happens is this buildings which are next to it again get affected. So these ground challenges, what we need to do is like what we usually do is we need to have groutings in place in advance for this overburden material in specific. Then we also do the ground instrumentation at the same time. Any single point we understand that this overburden material is causing any issue, we are always alert and we try to identify it so that it will not later convert into a major issue. So now I am talking about a case study which is related to that I'll be discussing now. So if you see, initially we have done this two big circles. You can see initially we have done this two boreholes only. You can see it is pre-construction boreholes. But then in these boreholes, what we have observed is there is a fractured zone we have identified. So what we have done is we have proposed some additional boreholes because we can see this Arabian Sea very clearly. So we have done these additional two boreholes just to understand how exactly the geology is varying when we are going towards the coast. We know when we are moving away, it would be at least better, but the worst case scenario would be in the sea only. So we have done this two additional boreholes. So if you see the geology, this is just a profile I have prepared. This particular zone indicates this zone is nothing but this one, which indicates that there is a presence of fractured rock material. However, when you are moving towards the coast, so these two boreholes are basically this side, indicates that the rock is intact. It will not have any much problem. So if you see this particular alignment, it is almost 100 to 150 meters. So what we have understood is at least up to this zone, there will be no problem in ground, but as soon as we are entering in this particular zone, this half of it, there can be some problems. Now, problem is identified that there can be a problem. There can be a fractured zone, there can be a high water ingress. So what to do now? So we have done additionally geophysical investigations along this entire line of 150 200 meter. If you see, we have done both the tests, seismic refraction as well as electrical resistivity, because uh, again, as per my experience, what I have understood is you cannot just go with one specific test. If you have at least two specific tests and then you relate with the core hole logging, you will be able to relate it, and then you can have a better interpretation of the ground anomalies. So if you see here, there are small fractured zones. Although rock type is still basalt, but you have small fractured zone in between, and these zones becomes water passage later on when you do tunneling. So if you see this particular image along the tunnel alignment, it's still okay. However, as you are moving this side, you can see this particular layer, it is going down. So this particular, again this. So this geophysical testing section is a tendency of ground becoming more fractured, because this particular image is indicating the velocity. So less velocity means ground would be of low strength. Whereas on this side, if you see, this layer has gone up, and then you have a below, you have a more than 2400 meter per second velocity. However, when you go this side along the tunnel alignment, this indicates that near the crown you have a velocity of only up to 1100. So again, this also confirms that there is a problem. So this is a resistivity 3D profile. So resistivity profile also indicates that on top or when you are moving toward the sea, there is no issue. No issue in a sense that it indicates high resistivity. This green, red, and yellow ones indicates high resistivity. However, at the bottom side, you see a lot of blue ones, which or water saturated. So then, so until now, what we have identified is there is a fractured zone. Geophysical test confirms it, but what to do next? That is the question. Now, if you see the practical image, this particular zone here. So what we have done is this particular area we have planned for grouting. We have designed grouting. We thought that why not to grout the ground so that it becomes competent and it becomes devoid of any fractures, so that there will be no water seepage when we do the tunneling part. So if you see, there are three different dots I was indicating primary grout line, orange ones indicated secondary grout of line, and green ones indicated tertiary lines. So these tertiary lines are only for the overburden. The previous slide I was talking about this overburden which causes a lot of issues. So these but this particular line is because ultimately this overburden soil can also pass through this subvertical joints, because these joints are also open as we have seen in this image. That is the reason this tertiary line we have planned only for overburden. Now this primary line goes up to the tunnel inward, and then we have a tamp grouting method. Grouting, we give pressures at certain ranges so that it become the fractures become intact. We follow bottom of approach, so basically we goes down up to the invert, then subsequently we move up, we apply different ranges of pressures at different stages. This is again being done in a three stage. So ultimately, what we have achieved through this is we believe that the ground has become intact, and at least it will differentiate, or I should say, it will substantiate some sort of issues. Still, we know that it will not completely eliminate it, because this particular location, like I said, we have slums which has caused an issues. Hello.
Hello, I think Mr. Anshul, your internet has been disconnected.
Please all mute yourself. Okay, I'll do. It seems okay now. Yeah. So if you see here, we have done this grouting, and then there were some indications during the drilling which we were doing it for grouting also. I'll just show one video here. You can see a lot of water is coming out post drilling. We haven't done anything. This is just post drilling for grouting purpose. This water was coming out like anything. So it indicates that there is a pressurized water sitting below, because this Mumbai is a, initially, if we go back to history, it is composed of seven different islands, and later we call it as Mumbai. So there is a lot of history associated with it, but if we relate it to our sitting below, and when you disturb it, this sort of uh, water pressure comes
Mr.
out. So
Anshul,
imagine, yes, sir.
hello. I think there is some, disconnectivity in between, or the voice is getting feeble. So you can just go into maybe just, video off mode actually, and then maybe delivery. You can deliver.
Yeah, it has improved, sir, now.
Yeah, we are able to see now. Yeah, it's improved. I think yeah, it's okay. You can move a bit. Yeah, can come closer to
Okay.
mic, or maybe, yeah,
Yeah. Okay, sir.
please go ahead.
Yeah. So, yeah. So, point here is, if you imagine the same type of tunneling we are going to do in a horizontal direction, how much water ingress. So now during the actual tunneling condition, same thing has happened. Wherever we have done this grouting, they exactly in this particular zone, there were some water seepages which we have experienced. However, since we were prepared in advance that this sort of problems can come, we have arranged for high dewatering pumps, so that whatever the water comes out, we can dewater it at the same time, so that tunnel doesn't get flooded. So those sort of arrangements were done. At the same time, we have done the face inspection. So we were well aware that for us, for some part of tunneling, this problem can come. So we were prepared for it, and it has, although caused a production significantly, but then we were able to counter it in a better manner. Had it been we have not understood all these aspects and we haven't done anything, definitely it would have created much more problems. That is what we believe. So just to conclude on a uncertainty minimizing in grounds, specifically for urban tunneling, these are the specific points which I have just listed down. See, understanding the regional and until and unless you don't understand the regional geology, you will not be able to understand the local part of it. Just for an example, I'll take again a Mumbai example. The shale with tooth pants is quite famous in Deccan Traps. You take any paper who is describing the geology of Mumbai, most of the authors are describing the geology of Mumbai in the same way. So we were aware in advance that this is the sort of geology which can create lot of problems. So that is the reason I said regional geology and local geology is important, and then you conduct the geotechnical investigation, because we know in urban there is no natural rock outcrops. So ultimately, understanding the regional and local geology will help you in planning the geotechnical investigations. Now, what happens is many parameters in geotechnical investigation of boreholes, depth
Yeah,
of
Mr.
boreholes.
Anshul, I'm
Yes, sir.
sorry to interrupt. There is some connectivity issue in between, the voice is getting off actually. So
Sir, what I
in between the voice is getting off actually. It's not audible actually. So it's difficult, like missing links are getting increased.
A little bit, in between sentence words are missing.
Maybe can you
I'll
check
just
out
switch
your,
to.
yeah, internet connectivity is okay? Only in between, it's now and then it's coming. That's a issue. Just have a look at the connectivity. Maybe other applications you can reduce and then you can go ahead.
Hello.
Yeah, yeah. Mr. Anshul,
Now
please
it's
go
better,
ahead.
sir. Now
Yeah,
it's
please
better.
go ahead. Yeah.
I've just switched to another connection. Hopefully, it will work now.
Okay, okay, okay. Please go ahead.
Yeah. So I was talking about the second point, which indicates that there are many parameters in geotechnical investigations which can always optimize, like spacing, location, depth, number of boreholes, what are the in situ testing, what are the lab testing types, frequencies. See, what happens is like, again, I'll take an example of Mumbai. There are contractual obligations, like we need to have only every 250 meter, we need to have one borehole along the tunnel alignment. This is a contractual requirement. But as an underground team or as an underground specialized engineer, we felt that considering the geological variation within Mumbai, we cannot afford to have a spacing up to 250 meter. We have reduced it further to 100 meter only. We know it may cause some extra penny to our company, but at the same time, we can avoid much bigger problems in future. So these spacings of and locations can be optimized if you are well aware of the regional and local geology. At the same time, you should have a proper conviction that what I am doing is in the best interest and it's the best understanding of ground. So you will get this conviction only when you know the regional and local geology. That is the main point here. Now, again, I initially mentioned that geological investigation should not be limited to boreholes drilling only. I've taken this example of this location nearest to sea. When we felt there is a fractured ground, at one side it is showing, at another side it is not showing. We cannot have 100 boreholes at that location. So the best way to move out is we have done additional geophysical investigation and then related with geotechnical investigation. And believe me, it has further improved the ground interpretation to our knowledge, and that is how we have planned to cater these problems when we were doing the tunneling. Now, involvement of geologist and geotechnical engineer is, anyways, I am sure you all must know that it is a critical point, and every good company usually have these experienced professionals. Point here is we should include them, and without them, we should not move forward. In case, sometimes what we used to face is, in case of Chennai specifically, what we faced is majority of the tunnel alignment was below the buildings. Now we cannot dug the building boreholes below the buildings. So what we can do is we need to find some suitable locations. There are some small rigs available in advanced technology. We can use them. Then we can have geophysical investigation. But we should not say that if there are buildings, we cannot do it. There are always ways of doing it. It is just that we need to see how we can plan for it. So this is the last point, which after which I'll conclude. So the major way of minimizing the uncertainties during the TBM tunneling is to have a map and continuously map the ground. If you don't do it, a TBM operator or your tunneling team can say that we can dig it, whatever it is. But as a underground specialized engineer, you should always keep in mind that without mapping the ground, nobody will come to know what exactly it is, and it may give some indication of what is coming in nearby the TBM phase. And if you not do it, you will miss it, which can again hinder the progress. So you imagine, like I've shown this photo specifically for a purpose here. You see the picture where I've taken the cutter head photo. You can see there is a lot of soil here. If you see this, there is a soil here. The next moment you can see a rock. This is a specific case of Delhi Metro in the project where what we have encountered is a full face hard quartzite rock. Just after like 5 meters before, we were getting full face soil, and then suddenly we got this hard rock quartzite which is of strength 300 MPa. So, like I said, if you don't do it, you will miss it. So these are just the some achievements I have indicated here. If you see this particular image, this is the exact scenario what we have done. Both sides we have heritage buildings. Below we have done this tunneling. It is one on this side, then one on this below these buildings. So this is again a bird eye view. You can see both sides we have heritage buildings. Below these heritage buildings we had our TBM, NATAM and TBM tunnel both, and this side we have a station. If you see this completed tunnel view, we have used a crossover TBM, which is first time being used in India. It is have a specific feature of horizontal screw conveyor. Generally, you might have studied in EPB TBMs, we have an inclined screw. But in this case of TBM, we have a horizontal conveyor screw and high torque, high speed, basically 2-speed cutter head drives. One is hard rock mode, another is EPB mode. This is a breakthrough images. So we have already completed this tunneling almost a year back. And with this, I would like to conclude. Thank you.
Okay, thank you, Mr. Anshu. So, kind of read the presentation on the screen because some people have any questions. They can.
Okay, sir. I'll present in case if there is a necessity. I'll have a screen share.
Okay, fine. So yeah, the session is open to questions. So please, if you have any question, you can ask. So anyway, till time, all of you think of your questions. I have certain of my own. So you talked about influence zone beyond the tunnels on the both sides 50 meters. So is it a standard practice or you do some numerical simulation and arrive at that 50 number?
Okay, thank you for the question, sir. Like I said, this influence zone of 50 meter is like a fixed criteria across all the metro projects within India. Now, the reason behind is, like I said, is they have taken the worst case scenario. The worst case scenario in terms of ground is, let's say, a silty soil with a high water recharge. So it is like a flowing ground. So what the previous people, like those who have basically write down the contracts, have experienced that even though with the worst ground case scenario, you have an influence zone which can affect the buildings up to 50 meter of maximum length. But this is just a criteria to fulfill in respect to the building condition survey. But like you talked about the numerical simulation and ground movement studies, which even I have talked about. Now, this particular will be an additional work which will be doing it during the construction stage to arrive at our project criteria where this buildings will be affected. Like I said, in case of rocky ground conditions, our maximum influence zone was 10 meter. For building condition survey, we'll be following this 50-meter zone criteria, but for our instrumentation purpose, we will not install the instruments 50-meter ahead, 50-meter far. We will install only up to the zone which we have identified during the numerical simulation. And it is like I said, in this case scenario, 10-meter only.
Okay. Also, some things about the cutter discs. So you said we have alternate, we have soft ground conditions and we have hard rock mass conditions. So what I have, we have studied is the disc cutters perform very poorly when you have soft ground conditions, like such as clay conditions. So then, how do you deal with if you have, tunnel boring TBM and with only disc cutters? Then how will you do?
Ideally, what I have experienced is now let's say this is a case scenario which has to be ideally taken care of during the time of planning of TBM, like selection of TBM stage itself. Let's say if you have a soil only, then you will not have any cutter disc. But in any case scenario, you have brought a TBM which is having a cutter disc as well as high opening ratio, we call it. So there is a case where we are anticipating both hard ground and soft ground conditions. In that case, you cannot avoid this cutter disc, that is for sure. But during the time of let's say when you are encountering soil, what we do is we remove some cutters, and we usually have higher opening ratios in the cutter head to deal with soil ground conditions.
And also, in the last slide, we talked about ground mapping. So, since
Yeah.
let us say we are working earth pressure balance mode, EPB mode, and
Okay.
then in that case, how do we map the ground? Because we are not, easily the gutter head face is not accessible to us in that case. Then how we will know what
See,
kind of geologist present ahead?
yeah. See, in EPB TBMs or even in slurry TBMs or even in compressed air TBMs. So EPB is nothing but a compressed air only. See, what happens is after the like once you have excavated for a let's say single ring, which is of width 1 meter or 1.5 meter, you must be like majority of the metro projects are using single shell TBM. So basically, if you have excavated for one segment, you will not excavate further. You have to first install the segment. So there is a time in between. So that chamber can be like basically vacated, and there will be a location at the top from where we can access it. And see, it cannot be 100% for sure, but at the same time, there are provisions in EPB as well where from the top compressed air chamber you can enter into, because these sometimes, like you said, in mixed ground condition, still you have cutters also which needs to be changed, and some picks also needs to be changed. So people access it. It's not that just the geologist goes; it's mainly the mechanical team which goes first.
Okay.
I hope you have understood.
Yeah, yeah. So, and one more thing, when we are entering those chambers, so there is high pressure, zone there. So, any health hazards regarding that? Comment on that.
See, there is basically first aid kit is being provided. Uh, there is a medical box. We call it as medical box, which is placed inside the TBM. So specifically in case of compressed air chamber, there are specific provisions and specific laws which needs to be followed. In terms of hazard, I don't think it presents much, but yes, when in case there is any gas presence, otherwise, I don't think there is any, but there are certain checks, medical checks needs to be done before entering compressed air chamber.
And one more question. So, is there any indicator that like we have to replace the cutters now? You are, some time of tunnel driving has happened, and then is there any indicator in terms of the thrust force or cutting forces which you are monitoring?
Yes, yes, yes. There are two ways. First is, of course, there are many people nowadays. Advanced version has come, so people are even placing certain sensors to check the, I should say, how exactly the cutters are working. it would be specific to specific cutter location. But then, as an operator, TBM operator gives you a lot of indication, because what happens is your thrust and not thrust, specifically torque varies a lot. Like imagine there is a ground which is consuming around 1,000 to 1,500 kilonewton meter of torque in general. But when there is a cutter, which there are many cutters which needs to be replaced, the torque will increase. So when the torque will increase, even when you know this ground doesn't consume more than 1,500 kilonewton meter, so the TBM operator will get to know it is because of which reason, and it is only because of cutter distance. So those sort of, I should say, desi jugaads work, or I should say the experience of operators also work.
Right, right. And also when we are replacing the cutter, we are replacing all of the cutters in that cutter head, or some chosen ones.
No. There is a check for, see, for face cutters, for gauge cutters, for center cutters. There are specific readings which need to be maintained. You have this V-shaped cutters, no? So there is a specific scale being given by the TBM manufacturer that, let's say, if it is a face cutter, this much tolerance needs to be there. If it is not there, so every individual cutters are being checked during cutter head inspection. Whatever the whichever the cutters are not basically in that particular range are being replaced.
So any frequency of that cutter head inspection, can you comment on that?
Again, it depends on the ground. Like in our case scenario, see, because it is an initial learning of 500 meter of any tunneling project, we usually do. Like within the first 500 meter, if let's say the general geology is not changing, like in our case scenario, there were only two major rock types. So we know that within the first 500 meter of tunneling, we'll get to know how much is the frequency after which certain cutters needs to be changed. So in our case scenario, somewhere around every 50 meter, we used to have a cutter head inspection. Sometimes we need to change, sometimes we may not need to change. But our frequency, what we have finalized is up to 50 meters.
So any other students?
Yeah, so in case, another example I'll give you, in case of Delhi Metro, where I was just telling about, we had encountered full face quartzite. So that TBM was actually not even, I should say the cutter head design was not specific to 350 NPA rock. So when we have encountered, every single day we need to change the cutter. So it really depends on the ground.
Any other students who want to ask? Can please ask. I'm only asking you. I think you are in front of your screens, or you have slept. Nobody can be sure in online lectures.
Any questions from student side, particularly those who are working or learning this tunneling? Particularly, I think maybe tunneling students can ask a couple of questions.
So I have one more question. So we study about performance prediction models. How accurate are they in your experience?
I mean, it's very difficult to answer that, because I'm like you have already mentioned, I'm working on the same program. But it like the theory works well. It is not like something, different direction they have chosen. It works well, but then it also depends on the geological variations what we get in our projects as well. No,
Okay.
the theory is designed in a right way. Of course, we are also learning from the same. I have even personally compared with many of the theoretical models. It gives you a pretty good idea. There is no doubt about it.
Any questions from student side? एकदम साइलेंट है भाई, आप लोग कुछ पूछना नहीं चाह रहे?
पूछिए पूछिए, कुछ भी पूछिए, मतलब आप लोग पढ़ रहे हैं क्लास में.
I need to ask names, or you will come out.
Huh?
Should I name the student, or Any questions from anybody will come automatically.
Hello, sir.
Yeah, Akash, please
Yes,
go.
yes.
Go
Yes,
ahead.
sir. Sir, could you ever means have you feel that whenever the after the construction that the drawdown in the water table will happen, and what are the means the action that you have taken place? Any situation that you practically feel?
Drawdown. I mean, it occurs no doubt, but see what happens is it varies from case to case. Like ideally, during the project case scenario, if you know like talk about the contract part of it, generally what it says is post completion of any construction, or I should say in terms of tunnel, once the segments are being placed at least one next monsoon cycle we need to monitor, and we need to see, because sometimes what happens is it depends on the timing when you have installed the piezometer, specifically for, let's say, you talked about drawdown levels, right? So if you have installed a piezometer, let's say in a monsoon season where the water level was already on a higher side, so you need to face another one monsoon cycle, and in between there will be days when this summer zone will also come. So in that particular time zone, your drawdown will go down. So it is actually not a real drawdown. It has happened because of the actual case scenario. I have not included some of the readings here, but if you see, we have installed many of the piezometers during the first day of the project itself, and it is of last 5 years data. If you see, there are actual sinusoidal waves it has formed. So it clearly indicates the fact that the drawdown always doesn't happen because of the construction work. It is also because of the timing when you have installed, and then you have subsequently summer waves, and then you have a monsoon zones coming up. In any case scenario, let's say, let's assume the fact that you have a drawdown. So what you have to do? It could be because of see, ultimately somewhere drawdown has happened, means other side the water has definitely come out. So first you need to identify that. If you are able to identify that, then you can say that yeah, it has happened because of us. Now what to do? You may say that okay, you can fill the water from the top, you can recharge, you can use some recharge wells. That can work sometimes when you have a soily ground conditions. But in another case scenario, what you can also do is, sometimes what happens is drawdown occurs only exactly where you have an instrument. So you need to have, let's say, what you can do is you can experiment it. You can drill another piezometer in a 5 meter radius zone, in a 10 meter radius zone, just to confirm that whether this drawdown is only restricted to that 5 meter boundary, or it is across the zone. If, let's say, if it is across the zone up to 20 meters, 25 meters, then obviously recharge wells are the only way moving forward. But in case scenario, in a 5 meter radius zone, 10 meter radius zone, what you are saying, like what you are getting is there is no change in water level. The water levels were up to the previous level. In that case scenario, there can be a localized drawdown as well. So it really needs to be experimented, and at the same time to be understood why exactly it has happened.
Hello, sir. I'm Sushant. Sir, my question is on sinkhole. Sir, basically these sinkholes, why occurs and how we will prevent it?
Okay, thanks, Sushant, for a very common question in urban tunneling. See, majority of the cases where I have seen is because of the ground conditions mainly. Like usually when you have a soil case scenario, it could be generally in clay. I haven't seen, mainly in silty sands and sandy soil. Mainly I have seen what happens is you use EPB TBMs, and this pressure balancing is a very critical task. When you overdo it, it creates heave on the top. And sometimes when you don't balance it, or I should say you undermine the values, in that case, it leads to additional ground loss inside the TBM, and then it occurs, and basically it leads to ground loss, or I should say a sinkhole at the top. But point which we need to remember, or usually the tunneling crew always take care of, is to understand what is the amount of excavation you are doing and what is the theoretical excavation, because that is what ultimately helps you to understand whether there is any additional excavation you have done or not. Because ultimately, when you have done additional excavation, then only there will be a sinkhole because of the balancing of pressure issues. If you have excavated only what is required, then the chances are very less. So that is what we need to usually take care of. I hope I have answered.
Yes, sir. Yes, sir. It's fine.
Thank you.
Anshul, this is Srihari.
Yeah, hi Srihari, please.
Actually, in the TBM, while we are operating the screen, we can see all the machine parameters, what is happening. But as you told,